90%. That is the number that defines Madagascar. 90% of all the species on the island, plant, animal, reptile, amphibian, exist nowhere else on Earth. Not in a nearby country, not on an adjacent island, nowhere. You could travel to every other country on the planet and you would not find them. Madagascar has been producing life in isolation for 160 million years, and the result is a biological inventory so alien, so specific, so radically different from everything else the planet offers, that scientists have taken to calling it the eighth continent. A place where evolution ran a separate experiment for longer than the dinosaurs were alive, in conditions that produced results that no other geography on Earth could have predicted or replicated. This is Shadow Atlas. If you are new here, hit subscribe. I make videos about places like this every few weeks, and Madagascar is not a place you spend one video on. Let's begin. To understand what Madagascar is, you have to start with what it was. And what it was, for most of its geological history, was not an island at all. Madagascar was once part of Gondwana, the supercontinent that formed the southern half of the ancient world, the landmass that eventually broke apart to produce Africa, South America, Antarctica, Australia, India, and the Arabian Peninsula. The breakup of Gondwana was not a single event, but a long process of rifting and separation that played out over hundreds of millions of years. Madagascar separated from Africa during the early Jurassic period, approximately 180 million years ago. Then, roughly 90 million years ago, it separated from what would become India, drifting to its current position in the Indian Ocean off the southeastern coast of Africa, where it has been ever since. This is the geological foundation of everything extraordinary about Madagascar, an island separated from the African continent 180 million years ago, at a time when the world's fauna bore little resemblance to the fauna of today, began an entirely independent evolutionary journey. The lineages of plants and animals that were present on Madagascar at the time of separation had no further contact with the rest of the world's genetic pool. They evolved in isolation, in response only to the conditions that their island presented, unaffected by the extinctions and invasions and competitive pressure that continued to reshape life everywhere else. But not all of Madagascar's life arrived at the time of separation. Many of the island's most famous inhabitants, the lemurs, the ancestors of the fossa, arrived much later, on what seems an improbable route. They rafted, not deliberately, but on mats of vegetation that detached from river mouths during floods and were carried by ocean currents across the Mozambique Channel to Madagascar's western coast. The Mozambique Channel today is approximately 400 kilometers wide at its narrowest point, and the currents in it, during the Eocene epoch when the early lemur ancestors likely made this crossing, may have been more favorable than today. A piece of bank vegetation detached by a storm flood, carrying a small primate or a mongoose-like carnivore on it, drifting for days across open ocean, eventually grounding on a coast that had no competing mammals of similar size, no predators of equivalent threat. This is how Madagascar's most famous animals arrived. And when they arrived, they found an island with no competition. The absence of the large mammalian groups that dominated African and Asian ecosystems, no big cats, no wild dogs, no primates, meant that every successful colonizer had evolutionary space to fill. A single mongoose-like ancestor that arrived roughly 18 to 24 million years ago radiated over subsequent millions of years into all of Madagascar's endemic carnivores. A single lemur ancestor radiated into more than 112 species, filling ecological niches that monkeys and apes occupy on the continents. A single ancestor of the tenrec, a small insectivore, radiated into everything from tiny shrews to water-dwelling creatures that resemble otters. Madagascar did not fill slowly with diverse arriving species. It filled quickly with the diverse descendants of a very small number of species that arrived and, finding themselves in an empty theatre, became the entire cast. The result is an island that looks, biologically, like nothing else on Earth. Not like Africa, despite being its closest neighbor. Not like any other island in the Indian Ocean. Like itself. Like the specific product of 80 million years of evolutionary isolation, operating on a geography of rainforests and dry deciduous forests and spiny deserts and high plateau grasslands, producing forms of life that the rest of the world's biology was not moving toward and would not have produced if given the same amount of time. Among the most ancient descendants of that original lemur raft crossing is a primate that lives in a narrow strip of eastern rainforest. In the mist-covered montane forests between sea level and 1,800 meters elevation, and that produces a sound that stops visitors in their tracks the first time they hear it. The Indri is the largest living lemur. It weighs up to 9.5 kilograms, roughly the weight of a large domestic cat, stands 60 to 90 centimeters tall, and has the general silhouette of a panda, round-eared, black and white, with a face that looks disconcertingly designed for expression. Unlike virtually every other lemur species, the Indri has almost no tail, just a stub of a few centimeters. It leaps between trees on powerful hind legs, vaulting gaps of up to 10 meters, with the kind of casual ease that makes the watching human feel immediately aware of the inadequacy of human locomotion. It is monogamous, a rarity among primates, and lives in small family groups of 2 to 6 individuals. And it sings. What the Indri does every morning, before the forest is fully lit, is something that primatologist Alison Jolly described in a phrase that has been quoted ever since. Indri sing the song of the forest, as whales sing the song of the sea. The call begins with a low moan that builds into a series of rising, modulating wails, eerie, melodic, deeply resonant, carrying for up to 2 kilometers through the forest. In a 2021 study published in the journal Current Biology, researchers who spent 12 years sampling Indri songs found that the calls conform to specific musical rhythms, a 1-to-1 rhythm like a metronome, and a 1-to-2 ratio like the stomp-stomp clap of a human musical pattern. This rhythmic structure had previously been found only in humans and certain songbirds. The last common ancestor of humans and Indris lived approximately 77.5 million years ago. The fact that both lineages independently evolved this same rhythmic structure in their vocalizations is, according to the study's authors, evidence that human musicality has deep roots that predate the primate lineage. The Betsi Misaraka people of Madagascar's eastern coast have their own knowledge of what the Indri's call means. They call the species Babakoto, ancestor of man, and their traditions hold that the Indri is a relative of human beings, that killing one brings terrible consequences, that the animal's status as a near person places it under a form of protection that comes from reverence rather than regulation. In many communities, this cultural taboo called Fadi has historically done more to protect the Indri from hunting than any government conservation program. The taboo is weakening. Poverty and food insecurity are driving hunting even in communities where Fadi once held. And the Indri has a biological characteristic that makes its situation especially precarious. It cannot survive in captivity. No zoo anywhere in the world has successfully kept an indri alive for more than a year. Every individual that exists in the world exists only in the wild, in the eastern rainforests of Madagascar, in a habitat that has been reduced by deforestation to a narrow corridor of increasingly fragmented forest. Fewer than 10,000 individuals are estimated to remain. The morning song that carries 2 kilometers through the canopy is a song that may not be heard a century from now. Madagascar's lemur diversity extends far beyond the Indri. There are more than 112 species, ranging from the Madame Berth's mouse lemur weighing 30 grams, the world's smallest primate, small enough to fit inside a matchbox with room to spare, to the now extinct giant lemur Archaeoindris, which weighed 200 kilograms and was the largest primate to have lived outside Africa and Asia. The diversity of forms, behaviors, and ecological roles occupied by lemurs is a compressed demonstration of everything evolution can do in millions of years of uninterrupted experimentation. The eye, with its elongated middle finger for tapping into wood and extracting insect larvae, has converged on the woodpecker's ecological role through a completely different mechanism. The sifaka, which cannot walk on all fours, travels on the ground between trees in an upright, sideways hop, a form of locomotion so distinctive and so odd-looking that it has been described as dancing. And watching a sifaka cross a road in the morning is one of the most purely joyful wildlife encounters available anywhere. Madagascar's apex predator, the fossa, is also unlike anything on the African mainland. It looks superficially like a cross between a puma and a mongoose, which is appropriate, since it is actually an enlarged relative of the mongoose lineage, the product of the same single carnivore ancestor that colonized Madagascar roughly 20 million years ago, and then expanded to fill the predator space that Africa's cats and dogs occupy elsewhere. The fossa's ankle joints are flexible in ways that allow it to descend trees headfirst, like a squirrel. It can pursue lemurs through the canopy with the agility of a cat and track them on the ground with the persistence of a dog. It is the only predator on Madagascar that regularly hunts lemurs, and its presence in a forest is the clearest indicator that the forest is intact, that the ecosystem is functioning, that the full chain of relationships that evolved over millions of years is still in place. Before humans arrived, Madagascar's skies were patrolled by elephant birds. Aepyornis maximus stood 3 meters tall and weighed nearly half a ton. The largest bird that ever lived, larger than any living bird by a significant margin. These flightless ratites had been part of Madagascar's fauna since before the island fully separated from Gondwana. They laid eggs that held approximately 2 gallons of liquid, the equivalent of 160 chicken eggs. Their bones are found across the island. Human beings arrived in Madagascar approximately 2,000 years ago, recently, by evolutionary standards. Recently, by any historical standard, and within a millennium, the elephant birds were gone. Not declining. Gone. The direct relationship between human arrival and megafauna extinction has been documented repeatedly across the islands and continents where it has occurred, and Madagascar is one of the clearest examples. What 160 million years of evolution produced and protected, 1,000 years of human occupation ended. In western Madagascar, in the Melaky region, roughly equidistant from the west coast and the center of the island, there is a landscape that the rest of the planet has no equivalent for. The Tsingy de Bemaraha is a UNESCO World Heritage Site, covering more than 1,500 square kilometers of the strangest geology on the surface of the Earth. Tsingy is a Malagasy word. It comes from mitsing itsingi, meaning walking on tiptoes. The name describes the physical reality of attempting to move through this place. The limestone of the Bemaraha Plateau was laid down as marine sediment when the sea covered this part of Madagascar millions of years ago. Over geological time, it was compressed into rock, uplifted by tectonic forces, and then subjected to a process of erosion that is specific in its mechanism and extreme in its results. Rainwater, slightly acidic from absorbing carbon dioxide in the atmosphere, seeps down through cracks in the limestone and dissolves it from below. The rain attacks from the surface at the same time. The combined vertical and horizontal erosion, operating over millions of years, has produced a landscape of limestone pinnacles, spires, needles, blades rising from the plateau in formations that range from 1 meter to 100 meters in height. The pinnacles are razor sharp at their edges. The gaps between them are too narrow for a human body to pass through. A fall onto the Tsingy is not a minor injury situation. Standing at the edge of the Great Tsingy and looking across the plateau is genuinely unlike any visual experience available anywhere else. The comparison that visitors most commonly reach for is a forest, a stone forest, an alien forest, a forest made by time rather than biology. The spires rise in such dense formations that the stone does appear, from a distance, to have the quality of vegetation to have grown from the plateau rather than been carved from it. Some spires reach 100 meters. Their faces are scored by the erosion patterns that created them, horizontal bands of harder and softer limestone marking the geological layers laid down over millions of years of marine sedimentation. In the deep shadows between the spires, where the sun never reaches, vegetation has found purchase trees that grow in the only spaces available to them, their roots threading down through limestone cracks to groundwater far below. These gorges, where forest survives in the shadows of the stone, are the habitat corridor through which the Tsingy's wildlife moves. To access the Great Tsingy, visitors use a system of suspension bridges, metal ladders fixed to cliff faces, and steel cables as climbing anchors. The infrastructure is not there to make the experience comfortable. It is there to make it survivable. Without it, the Tsingy is inaccessible, which is why the wildlife within it was largely protected from human pressure for thousands of years. The very hostility of the terrain was the conservation mechanism. Animals that colonized the Tsingy found within its impossible geography a refuge that nothing else could enter. The result is an ecosystem of exceptional density and species richness, preserved not by a government decision, but by the simple fact that walking barefoot here would result in puncture wounds that require immediate medical attention. 13 species of lemur have been recorded in the Tsingy de Bemaraha. Deccan's sifaka, which has adapted to leap between limestone spires with the same casual confidence it would use for trees. The red-fronted brown lemur, the western bamboo lemur, the pygmy mouse lemur, which weighs less than 50 grams and can fit inside a human fist. Over 100 species of birds have been recorded, including the critically endangered Madagascar fish eagle, which hunts the rivers that cut through the Tsingy on their way to the coast. Chameleons are everywhere. Madagascar is home to 2/3 of the world's chameleon species, and many of the Tsingy's species are endemic not just to the island, but to this specific landscape. The caves beneath the Tsingy are their own world, where the groundwater erosion has created tunnels and chambers in the limestone below the plateau. There are cave systems of extraordinary scale cathedrals of stone that have never been fully explored that hide their own ecosystems of cave-adapted animals, that channel the underground rivers that emerge as springs at the plateau's edge. UNESCO described the Tsingy as representing the spectacular expression of a stage of evolution of the Earth, in the form of a forest of sharp stones, with high limestone pinnacles rising up to 100 meters, forming veritable cathedrals offering a grandiose, spectacular natural landscape. The language is formal, but the awe is genuine. There is a detail about the limestone spires that takes visitors by surprise. Despite their ferocious appearance, despite the fact that the word Tsingy specifically refers to terrain where you cannot walk barefoot, these formations are alive. Not symbolically alive, biologically alive. Mosses and lichens coat them in patches of green and grey. Small flowering plants find roothold in crevices where enough soil has accumulated. Ferns emerge from cracks where moisture collects. The stone forest is not dead. It is slow and patient, and covered in living things that have adapted to growing on the hardest, sharpest substrate available. Life on Madagascar finds its way into the Tsingy the same way it finds its way everywhere else on this island, by adapting to conditions that seem, from the outside, to be incompatible with existence. Drive west from the Tsingy toward the coast of the Mozambique Channel, and the landscape transitions from the highlands plateau through dry, deciduous forest to a coastal plain of scrub and grassland. And on a dirt road that connects the town of Morondava with the village of Beloni Tsiribihina, a road with potholes that require concentration and a vehicle with appropriate clearance, there is a 260-meter stretch that has become, over the past 2 decades, the most photographed location in Madagascar and one of the most photographed landscapes in the world. The Avenue of the Baobabs. In Malagasy, the trees are called Renala or Reniala, Mother of the Forest. The name is not poetic, it is ecological. Baobab trees, in the forests they came from, provided structure, shade, water, and food resources that organized the life around them. They were the mothers of their ecosystems, in the sense that the ecosystem depended on them to function. And the species that lines this road, Adansonia grandidieri, the grandidiers baobab, the largest and most dramatically built of Madagascar's 6 endemic baobab species, is among the most spectacular trees on Earth. 6 species, that is the other number that matters here. The world has 8 species of baobab. 6 of them are endemic to Madagascar. They are found nowhere else except on this one island, in a lineage that is estimated to have originated in Madagascar between 41 and 21 million years ago, and then dispersed 2 species, one to mainland Africa, one to Australia, by floating fruit carried across the ocean on currents. Madagascar kept the rest. 6 species, ranging from the small, squat, phony baobab of the western dry forests to the grandidiers baobab of the Avenue, whose cylindrical trunks can reach 3 meters in diameter and 30 meters in height, and whose oldest individuals have been growing since before the Crusades. The largest trees along the Avenue are estimated to be up to 2,800 years old. This estimation is not simple. Baobab wood is soft and fibrous, and unlike most trees, it does not produce consistent annual growth rings that can be counted to determine age. The estimate comes from trunk circumference measurements and growth rate models, and it has a wide confidence interval. But even the conservative estimates place these trees at several hundred years old, which means they were standing on this road when the Mali Empire was at its height, when the Mongol Empire was still expanding, when the Ottoman Empire did not yet exist. They were standing here before any European knew that Madagascar existed. They did not always stand alone. The avenue of the baobabs, as it exists today, these giant cylindrical trunks rising from a flat landscape of grass and rice paddies with no forest around them, creating the extraordinary silhouette that makes the sunset photographs so extraordinary, is not the landscape they evolved in. They evolved in forest. Dense, mixed, tropical dry forest that once covered the western coastal plain of Madagascar. Their trunks are tall and branchless for most of their height because that was the adaptation required to compete with the canopy around them to push their crowns above the surrounding trees toward the light. Now the surrounding trees are gone, cleared for agriculture over the past several centuries, and the baobabs stand in the open in a configuration that was never their natural condition. They are the survivors of a forest, monuments to an ecosystem that once surrounded them and has been dismantled. The Malagasy people preserved them not by formal conservation, not by government decree, not until very recently. They were preserved because they were useful. Baobab trunks store water in their fibrous tissue and can be safely tapped for drinking water during the dry season. Their fruit pulp is edible, rich in vitamins and nutrients, with a taste similar to tamarind. Their leaves can be eaten as a vegetable when other food is scarce. Their bark has medicinal uses. They were too valuable as a resource to cut down. And so, as the forest around them was cleared for agriculture, the baobabs were left standing in the fields. What looks, in photographs, like a monument to ancient wilderness is actually a monument to a very specific human decision that these particular trees were worth keeping. The National Monument designation, which was only awarded in 2015, came long after the avenue had already become internationally famous. Before 2015, these trees had no legal protection. The fires, floods, and agricultural encroachment that have been reducing Madagascar's forest cover for centuries continued right up to the trees' bases. The avenue is now protected, but the broader landscape of western Madagascar's dry forest, the ecosystem these baobabs were part of, and that most of the island's remaining western species depend on, is not fully protected, and the threats to it are ongoing. 7 kilometers northwest of the avenue, on an even rougher road that tests the patience of any vehicle, there are 2 more baobabs. These are not Adansonia grandidieri, but Adansonia za, a different endemic species, smaller in stature, but these 2 particular trees are notable for what they have done to each other over the centuries. Their trunks have grown toward each other, meeting and twisting together in a slow embrace that has been progressing for as long as anyone can determine. They are called Baobab amoureux, the loving baobabs. A local legend explains their entwining. 2 young people of a nearby village fell in love, but were already promised to others, and they asked their god to let them be together. Their god transformed them into 2 baobabs that grew beside each other, reaching toward each other, growing into each other. The legend says their love now lives on for eternity as one. It is the kind of story that a landscape earns. These trees have been growing in the same place for hundreds of years, in each other's company, slowly wrapping around each other in the time that empires have risen and fallen and the world has been remade. Whatever the actual mechanism, the way their root systems have interacted, the way their growth responses have been shaped by their proximity, the result is a visual statement about persistence and entanglement that no human story can improve on. They are just trees. They are doing what trees do, and they are extraordinary. Travel south. The further south you go in Madagascar, the stranger the planet gets. The southern tip of Madagascar, the zone below the Tropic of Capricorn, extending from the Mangoki River on the west coast to the Anosiens mountain chain in the southeast, is one of the most biologically unusual landscapes on Earth. It is a place that looks, at first approach, like a desert. The climate is arid. The rainfall is minimal, often measured in the low tens of millimeters annually. The sun is intense. The wind is desiccating. And the vegetation that covers this landscape is unlike any vegetation you have seen outside Madagascar, and specifically unlike the vegetation in any other desert on the planet. The spiny forest of southern Madagascar is the domain of the Didieraceae family, a group of plants found nowhere else in the world. These are the octopus trees, a Luardia species rising to 10 meters on thick, succulent stems covered so densely in spines that moving through them is not possible without shredding your clothing and your skin. The stems branch in forms that sprawl upward and outward in configurations that look, from a distance, like something between an octopus and a tree and an explosion frozen in time. The leaves, small, waxy, designed to minimize water loss, emerge from between the spines in the wet season and are shed immediately when drought arrives, leaving the stems bare and armed. The Didieraceae are not cacti. They are not related to cacti. The cacti of the Americas and the Didieraceae of Madagascar evolved their similar forms, spiny, succulent, adapted to extreme aridity completely independently, in response to the same environmental pressures. It is one of the textbook examples of convergent evolution. Two completely unrelated lineages reaching the same solution to the same problem because physics and biology, given the same conditions, tend toward the same answers. The spiny forest is the most biodiverse dry ecosystem in Madagascar, which is saying something in a country where every ecosystem has pushed its diversity to extraordinary levels. The percentage of plant endemism here is the highest in Madagascar, which means the highest of any equivalent area in Africa, with some of the dominant species having ranges measured in dozens of square kilometers. The animals that have adapted to live in the spiny forest have made their peace with the thorns in ways that range from pragmatic to spectacular. The radiated tortoise, Astrocalis radiata, has one of the most beautiful shells of any tortoise species. Its black carapace decorated with bright yellow lines radiating from the center of each scute in a geometric pattern that looks more designed than evolved. It is strictly endemic to this region. It has been here longer than any human record on the island. It navigates the thorns with the slow certainty of an animal that has never needed to hurry, eating the succulent leaves and cactus pads of the spiny forest as it has eaten them for millennia. Verreaux's sifaka, a large white lemur of the southern dry forests, has the same challenge on ground that all sifakas face. Its legs are designed for leaping between vertical supports, not for walking. When it needs to cross an open section of ground, it cannot simply walk. It goes sideways. It raises its arms, balances on its powerful hind legs, and bounds laterally across the ground. The sifaka, crossing a patch of ground between spiny trees in the southern forest, its white fur catching the morning light, its arms raised, bounding sideways through the thorns. This is one of the most distinctive animal behaviors available anywhere in the world. It is not trying to be remarkable. It is simply moving in the only way its body can move. The remarkable is built into it. The grey mouse lemur, the smallest primate in Madagascar's south, goes further. During the dry season, when food is scarce and the spiny forest has reduced its leaves and the insects are less abundant, the grey mouse lemur enters torpor, a state of reduced metabolic activity similar to hibernation. It stores fat reserves in its tail and its body over the wet season, and when the dry season arrives and the landscape reduces what it offers, the lemur retreats to a hollow and waits. It can remain in torpor for up to 7 months. 7 months in a living animal the size of a human fist. The fact of a primate, however small, spending 7 months of each year in suspended metabolic activity is a solution so extreme that it speaks to the extraordinary severity of the conditions that produced it. There is a phrase that recurs in almost every scientific paper about Madagascar's biodiversity, and it is worth spending a moment on. The phrase is rate of description. It refers to the speed at which new species are being formally documented and named. In most parts of the world, the rate of description has slowed over the past century, as the planet's accessible biodiversity has been catalogued. In Madagascar, the rate of description is accelerating. More species are being formally named from Madagascar per year now than at any previous point in the history of natural science. This is partly because new survey methods, environmental DNA, acoustic monitoring, drone-assisted mapping are finding things that older methods missed. But it is also because Madagascar genuinely contains a large number of species that have not yet been encountered by any scientist, that exist in forms no human being has formally observed, that are moving through the forests and the spiny deserts, and that sing in total biological obscurity. The island that has been studied for centuries, photographed and visited and documented, still holds things that have not been named. This is what 160 million years of isolation produces, a quantity and a strangeness of life that exceeds the pace at which human science can process it. Madagascar is simultaneously the most extraordinary and the most endangered place of its size on the planet. More than 90% of the original forest is gone. Deforestation continues, driven by slash-and-burn agriculture called tavy, by charcoal production, by illegal timber extraction. The rivers run red with eroded soil. The species that evolved here over millions of years are being lost before they can be documented, before their functions in the ecosystem that supports them can be understood, before their evolutionary lineages can be traced. Scientists describe the situation in Madagascar as a crisis of extraordinary severity in a world that has no shortage of environmental crises. And yet that Tsingy still stands, full of lemurs adapted to live on razor limestone. The avenue still stands, the renala still holding their arms to the sky above the rice paddies. The Indri still sings in the eastern rainforest, every morning in the rhythm that we share with them from 77 million years ago. The sifaka still dances through the thorns of the spiny south. The radiated tortoise still moves through the octopus trees in the geometric beauty of its ancient shell. The window to see these things, to stand in a spiny forest that looks like no other forest in the world, or to hear the Indri's song carry through mist, or to watch Deccan's sifaka leap between limestone blades that would cut you to the bone, that window is open. But the deforestation visible from space, the red soil bleeding into the Indian Ocean, means it will not be open forever. Tell me in the comments which of these places you would go to first, and why. And where in the world are you watching from right now that genuinely matters to me more than you might expect? There is a detail about the Indri that has not been fully reckoned with in the public understanding of this species, and it matters to sit with it properly. The Indri cannot live in captivity. This is not a statement about conditions, about whether zoos could provide better care, or more space, or more appropriate food. It is a biological fact about the animal itself. Every attempt to keep an Indri in captivity has ended in the animal's death within months, usually within weeks. The reasons are not completely understood. The stress response of the animal to captivity appears to be catastrophic in a way that does not respond to management. The Indri is so specifically adapted to the conditions of a particular type of eastern Madagascar rainforest that removal from that forest is, for the animal, a form of acute biological failure from which it cannot recover. The consequence of this is that there is no backup population for the Indri. There is no captive breeding program. There is no ark. If the forests of eastern Madagascar are gone, the Indri is gone. There is no mechanism by which science or conservation can preserve this species outside its habitat. The only option is the forest. Either the forest is there or the Indri is not. What this makes of the Indri's song is worth thinking about. That call, the morning wail that carries 2 kilometers through the mist, the call that carries the rhythmic patterns shared only with humans and certain birds, the call that the Betsimisaraka people named Ancestor of Man. It is entirely tied to a specific forest, to the health of a specific ecosystem, to the survival of a specific island's natural heritage. It cannot be recorded and replayed from anywhere else. It cannot be heard at a zoo. It is available only in the eastern rainforest of Madagascar, and only for as long as the forest remains. The Baobab Avenue's history as a surviving remnant of a vanished forest has a dimension that photographs of the trees rarely convey the scale of what is missing. The 20 to 25 trees that line the 260-meter stretch are not a selection of exceptional specimens saved from a larger grove. They are the random survivors of a process of clearing that removed everything else. The forest that surrounded them was not exceptional forest. It was ordinary Western Madagascar dry deciduous forest, the same forest that stretches in increasingly fragmented patches from the Morondava region northward. As that forest was cleared for agricultural land, one by one the other trees came down, and the baobabs were left standing because their timber is not useful. The spongy, fibrous wood splits unpredictably and rots quickly, and because they provided food and water for the communities clearing around them, the trees that remain are not arranged in any way that reflects a planned grove or an original forest structure. They stand where they happened to be standing when the forest around them was cleared. Their spacing reflects nothing except the random distribution of individual trees in a former mixed-species forest. The avenue is an accident of survival, not a design. And this somehow makes it more affecting rather than less. These trees are not here because someone thought to preserve them. They are here because no one found it worth the effort to cut them down. And that accident of economics and practical usefulness is the only reason the most famous landscape in Madagascar exists. The Tsingy de Bemaraha's protection has a similar accidental quality. The limestone spires are not protected because someone decided to protect them. They are protected because no one could productively use them. Farming on razor limestone is impossible. Logging has no application in a terrain where machinery cannot be deployed and humans cannot walk without injury. The Tsingy protected itself for thousands of years by being inhospitable, and the wildlife within it survived because the inhospitability that kept farmers and loggers out also kept predators and hunters at a manageable level. The UNESCO designation and the park management system are a formal ratification of a protection that the geology itself had been providing. The deeper implication is uncomfortable. The most protected biodiversity in Madagascar has been protected by uselessness. The places that have been spared are the places that were too difficult, too steep, too sharp, too dry, too remote to be cleared for agriculture. The places that were accessible and fertile and easy to cultivate, the lowland rainforest of the eastern coast, the dry deciduous forest of the west, the coastal wetlands, those are gone or nearly gone. Madagascar's conservation record is a record of what survives when you remove everything that can be economically used. What remains is extraordinary. What has been lost was also extraordinary and is not coming back. This pattern survival by inconvenience is visible across Madagascar's different ecosystems. The Tsingy survives because its terrain is razor limestone. The spiny forest survives in its most intact form on the Mahafali Plateau, where the limestone and the aridity combine to make agriculture unreliable. The avenue of the baobab survives because the individual trees were too large to cut efficiently and too useful as a food and water resource to sacrifice. The Indri survives in the mist forest because the steep, wet, montane terrain of its habitat is difficult to clear and difficult to farm. In every case, the survival of the extraordinary has been a function of difficulty. The easy places are gone. What this means for the spiny forest specifically is that its future is more complicated than its present appearance suggests. The spiny forest looks intact. From the air, from a distance, it has the density and continuity of an undamaged ecosystem, but within it, the slow processes of degradation are ongoing. Charcoal production, the primary cooking fuel for most Malagasy households, requires wood, and the trees of the spiny forest burn better than the thorny shrubs that surround them. Radiated tortoises, whose population was once in the millions across the southern region, have been reduced dramatically by collection for the international pet trade and for local consumption during food shortages. The ring-tailed lemur, which uses both the gallery forests and the open spiny scrub, is classified as endangered not because the spiny forest itself is vanishing, but because the other habitats it depends on during different seasons of the year are fragmenting. The convergent evolution that produced the Didieraceae, the octopus trees that look like cacti but are not, is one of the most instructive phenomena Madagascar offers. Evolution, given the same conditions, arrives at the same answers independently. American deserts produced cacti with spines and succulent stems. Madagascar produced Didieraceae with spines and succulent stems. The two lineages share no recent ancestor and developed their similar forms over completely separate evolutionary trajectories, responding to the same physical constraints. Minimize water loss, maximize water storage, protect against herbivory. Physics does not care whether the plant is a cactus or an octopus tree. It responds the same way to the same pressures. The lesson of convergent evolution is not that evolution is predictable. It is that the physical universe has consistent rules, and when living organisms encounter those rules in the same configuration, they produce similar responses. Madagascar isolated itself from the rest of life's evolutionary trajectory for 160 million years and then reinvented independently from different starting materials, many of the same solutions that life invented elsewhere. Life is not arbitrary. It is responsive to physics. The same conditions produce the same solutions. Whether the starting materials are from Africa or South America, whether the evolutionary lineage is 20 million years old or 100 million years old. Madagascar looks alien because its biology used different starting materials than the rest of the world. But the underlying logic, the physics and chemistry of survival in aridity, the mechanics of locomotion in forest canopy, the acoustics of long-distance communication in dense vegetation is not alien at all. It is the same logic expressed through a different evolutionary vocabulary. The Indri's song is not strange because music is strange. It is strange because a primate from a lineage that diverged from ours 77.5 million years ago independently arrived at the same rhythmic patterns that human musicians recognize as fundamental. Madagascar is not the eighth continent because it is alien. It is the eighth continent because it is a parallel Earth, a place where the same physical rules produced life, but where the specific evolutionary experiment ran from different starting materials, at different rates, in different directions, for long enough that the results look like another world, while following the same underlying logic as this one. Go there, see it, hear the song. The forest that holds it is still there. The Malagasy people who have lived on this island for 2,000 years are not visitors to its ecology. They are part of it, a part that arrived late and has had an outsized impact, but a part nonetheless. The Fadi system of taboos that protects the Indri from hunting in many communities is not a coincidence or a fortunate quirk. It is an evolved cultural response to the recognition that certain animals occupy a special category of relationship with human beings. Babakoto, ancestor of man, is not just a name, it is a statement about the nature of the animal, about the nature of the relationship between the Betsimisaraka people and the forests they live in, about what is permissible and what is not. The taboo may not be framed in the vocabulary of conservation science. Its function is conservation science, arrived at through a different process. The Austronesian sailors who reached Madagascar from Indonesia approximately 2,000 years ago, making one of the longest open ocean voyages in the history of human seafaring to arrive on an island that no other human culture had reached, brought with them a culture that developed, over the centuries, an intricate set of relationships with the specific ecology of the island. The Malagasy relationship with the baobab trees is a relationship of utility and respect that predates any conservation designation. The Renala is the mother of the forest. You do not cut down your mother. These cultural frameworks for coexistence with Madagascar's ecology are not primitive precursors to modern conservation. In many cases, they are more effective than the systems that replaced them. The Fadi protecting the Indri has done more for the Indri's survival than government regulation, because Fadi is enforced by community belief and social pressure in a context where government enforcement is limited. The cultural respect for baobabs as food sources and water sources has preserved trees that no legal instrument protected until 2015. The Malagasy people's management of their relationship with their island's ecology over 2,000 years has been imperfect and has caused enormous damage, the loss of the elephant birds, the reduction of the forests, the erosion visible from space, but it has also produced, in places and at times, a form of coexistence that the rest of the world is still trying to figure out how to formalize. The rate at which new species are being described in Madagascar is not the only number that is accelerating. The rate at which known species are becoming endangered is also accelerating. More new species are being discovered per year than ever before. More species are being classified as critically endangered or extinct per year than ever before. Both are happening simultaneously, in the same landscape, driven by the same technological improvements, the environmental DNA surveys and drone mappings that are finding new species faster than previous methods, also reveal more clearly the scale of habitat loss. The chameleons of Madagascar are worth at least a brief accounting. 2/3 of the world's approximately 200 chameleon species are found on Madagascar. The island is hypothesized to be the origin point of all chameleons, the place where the lineage arose and from which species dispersed to Africa and Asia. The diversity of forms is extraordinary. From the Parsons chameleon, which can reach 70 centimeters in length and is one of the largest chameleons in the world, to Bruchesia micra, discovered on a small island off Madagascar's northern coast in 2012 and measuring at most 29 millimeters from snout to tail tip, one of the smallest reptiles ever described, small enough to stand on a matchstick head. Bruchesia micra was found in 2012. A related species, Bruchesia nana, discovered in 2021, may be even smaller, with males measuring only 22 millimeters, possibly the smallest adult reptile known to science. Both species were discovered in 21st century, on an island that has been studied by European naturalists for centuries. This is what 160 million years of evolution in an isolated laboratory looks like in practical terms. There are still things here that no one has found. The red soil that astronauts see from orbit is the most visible expression of what is happening to this biological archive. Every hectare of deforested land loses its topsoil to the rivers, and the rivers carry it to the sea as the red plumes visible from space. Madagascar's soils, once forest-covered and rich in the organic matter produced by millennia of biological activity, are extremely vulnerable to erosion once the forest is removed. The laterite soils of the east and the red sandy soils of the west both erode rapidly. What the rivers carry to the sea is not just soil, it is the future productivity of the land, the accumulated organic chemistry of millions of years of forest growth, the substrate that the next generation of forest would need to regenerate from. The erosion is not just a current problem, it is self-perpetuating. The more the soil erodes, the harder reforestation becomes. This is why the eighth continent framing matters. A country you have not visited is easy to discount. A continent that is bleeding into the ocean from orbit, that holds biology that exists nowhere else in the universe that has been discovered, that is losing that biology at a rate that exceeds the pace of documentation that is harder to discount. Madagascar is not a distant conservation concern. It is one of the most important biological archives on Earth, and it is in the process of being erased. The archive is not yet closed. The Indri still sings. The Tsingy still stands full of life that the razor limestone protects. The mothers of the forest still hold their arms to the sky above the rice paddies of Morondava. The sifaka still dances through the thorns. See it. The window is open. Use it